All right. Good morning. Happy Friday. Oh, I'm overwhelmed. All right. Oh, there was something I wanted to I did post some homework or an assignment on section 1.1, but I did make a note, right, that some of those later questions we're going to cover today. So if you kind of went into it and it felt like, oh, this is good, and then all of a sudden it wasn't that good, that's totally fine. Try it again after today. Okay. All right. So obviously I'm gonna adjust our schedule. See how far we get today. We're not getting through inverse functions today. That's nuts. Turns out that's nuts. All right. So continuing from last day, as a form of review, how do I copy? Or you know what? Let me do all of this. Oy. So usually I do review, but all we really did was we introduced, fine. We introduced this idea of a function. And so we introduced functions, oops, and function notation. Oops. Things like f of x is some y, right? And so we said, okay, well, x is the input that I put into this function f, and it does something to x, right? And then it gives me some output y. What was the most important thing that we said about a function? Function's only a function if an input gives a unique value of y, right? And we said multiple inputs could give the same value of y, right? That's fine. But the key is that each input can only yield one unique output. Okay. So here, in order to be a function, each input must yield only one output. And that's something that we explored visually as well, right? With the vertical line test. If you have a graph, then you can draw vertical lines. But all of those things are just emphasizing that each input can only give you one possible output. And then we started working on this question. Okay, we had this function g of k, which produces some value p. Okay, and g of k takes k and squares it, multiplies it by 3, and adds 1. And then we get the output, which we can call g of k or p if we prefer. There's no context for it, so it doesn't matter. Okay. And so the first thing we did was we evaluated g of -2, right? And remember, the term evaluate just means you plug in an input and you get an output. Whereas solving is when you are given an output and you have to solve, kind of work backwards to find the input that makes that true, right? That's the difference in terminology. Now, I wouldn't worry too much about memorizing that terminology, because even if you didn't have these words here, right? If it just said do g of -2. We would never say that, right? But if it said just do g of -2, you would know to put in -2 and solve, or sorry, and evaluate, rather, right? And then if I told you g of k is equal to 25, you would just know to solve for k. Okay, so that terminology, it's good to have in your back pocket, but it's not, you don't have to memorize it per se. So we solved for, or we evaluated g of -2. See, I mix them up because I'm sloppy like that. What if we have to solve g of k, or maybe I'll use a different color. How about green? That's a nice subtle color. Oh, and driving in today, remember how I said, oh, my mom calls Remembrance Day something funny? And I couldn't remember what it was. She calls it Novembrance Day, and she cannot shake it. And I really wish I hadn't remembered that, because now, yeah, Novembrance Day. She didn't grow up here, so it's hard for her. She grew up in Sweden, and we don't have Remembrance Day. We've got other things. All right. But there, I thought of it. It's driving Novembrance Day. Oh no, I wish I hadn't remembered that. So we're told that g of k is 25. Okay. And if we want to solve this thing, then what am I going to do? I'm going to replace g of k with what the actual function does. Okay. And I'm going to put that, I'm going to do a little switcheroo, because I like to be working on the right-hand side of the equal sign. Okay. And that's, so what I'm going to do is I'm going to say 25 is equal to 3k squared plus 1, I think. Yeah. Sorry, on my end, there's like a pen box here, so I can't see sometimes, but that's okay. All right. So now we're going to solve for k. All right. That's our goal here. Solve for k. And where's that green? Subtracting 1 from both sides, right? 25 minus 1 is 3k squared. So 24 is 3k squared. 24 divided by 3 is going to be k squared, right? To get k squared on its own, I need to shake it out, right? But I need to work my way inwards, right? And so I have to subtract 1 from both sides. Notice how I'm lazy and I don't write what I did on the one side anymore. I should, but I don't. Fine. Plus 1 minus 1. In red is all the things that I should have written, but I don't. And it's okay if you don't either, right? We'll kind of outgrow that. But just in case it's a little rusty still, then I'll need some room here. I'll do this. Right, in order to shake that 3 multiplier, I'm gonna have to divide both sides by 3. And what is 24 divided by 3? I don't know. Thanks. I would have got there. But it's still early. And these 50-minute blips, we're just going to get warmed up and then all of a sudden it's going to be over. It's crazy. So that's something to look forward to, I guess. To shake that square, we have to take the square root of both sides, right? And so here I'm going to say boink. I like to put a little cap on my square root, but I will show it on this side. And this cancels my square with the square root. And so then K, and now I'm going to switch them back, confusingly. No, don't switch them back.
No,
It's good?
Yeah.
Did I do something wrong?
No, I like how you switch it back.
Okay. Revolving door. All right. K then is the square root of 8. Ah, that's what the head shake was about. I'm still waking up as well. I'm glad some people are awake. It's great. I will confess that I'm really good at forgetting the plus minus on the square roots, but I get there eventually. All right, so right, any negative number squared makes a positive, and any positive number squared is also positive, right? And you can see that from the graph of a parabola, which we haven't seen yet, but you might remember, right? X squared looks like this. And so that's why it's plus minus once you take the square root. Which means that there are two values of K that give you the same value of G of K, right? And that's fine. All right. I tried to remember to do a little end of review, just to indicate end of review. It's like a little the end. It's all cartoony. The end. Oh, and I've got a fresh page here. So start fresh for new material today. So I do review, and sometimes it's quick and sometimes it's slow, and it just depends on where we're at. Just like if I asked you to tell me what this shape is, or what this shape is, or what this shape is, right? We know the names of those shapes, right? And so what we're building towards is there's going to be kind of the textbook calls it a toolkit of functions that we need to be able to recognize quickly, right? Things like a straight line, right? You might remember that, okay, the equation of a straight line looks like y equals mx plus b or some version of that, right? And so we're going to build some functions or a toolkit of functions that we're able to recognize the equation of, okay? And we'll know the shapes of them and just some key information about these functions. Okay? And so let's see here. Where are these? This toolkit functions. I'm gonna snag this whole thing. So first we're gonna introduce them all, and some of them we've seen already, right? And so that's nice. I want to make it bigger. Oh, sorry guys. Got it. Okay. Phew. So we've already seen some of these toolkit functions, right? We can have a linear function where we just have some straight line at some constant, then we say f of x is equal to c, where c is a constant, of course, a number. So f of x equals 3 just means that you have a straight line at 3. And I'm not graphing them. I'm trying not to graph them because we'll see the graphs in a little bit. So I don't want to be redundant. But we can talk about the identity straight line. F of x equals x goes across the diagonal, for example. And we also talked about mx plus b, or ax plus b, or a plus bx. That's weird. Right. You can mash it up whatever way you want, but whatever is attached to the x in a straight line function is the slope, and the one on its own is the intercept, but we'll work with linear functions later. The absolute value function is, what does the absolute value do? Right, the absolute value takes any number and turns it positive. Doesn't really matter for positive numbers, but if I take the absolute value of -4, then it returns 4, right? So it drops the negative. Little reminder here, right? It is a little bit more sophisticated than just dropping the negative, right? But just to remember, right, for now, just drops the negative. It is a piecewise function that we have not seen yet. We need to recognize a quadratic, right? Any term of x where the highest power is 2 is a quadratic. And maybe I'll jot that down. Highest power of x is 2 is a quadratic. Same thing with 3 is a cubic. And there are names for quartics and things like that. But these are just like the toolkit functions, the ones that we need to know our way in and out of, right? And weave through quickly. Okay. Kind of like the times tables, I guess. Did you guys do mad minutes?
No idea what that is. That's like 12 years, 15 years ago, I remember hearing that.
So a mad minute when I was in grade school. When do you learn multiplication? Grade 3, 4, probably. Huh? Oh. Yeah, he'd be a mad minute type of guy. So a mad minute is you have a minute to do 100 multiplication questions. So they give you a sheet and then you, and we would do it. It was crazy. Well, thinking about it now, yeah, just, and you can do it as long as you've practiced, right? And so it's crazy to think of now. I could not do that anymore, but it's definitely a skill that you can work up to. And they used to make us do it in grade 3, 4, mad minutes. So we moved back and forth between Sweden and here quite a bit. And so I skipped some grades and I did some grades over again because of moving back and forth. They are a year behind. So to stay with the same age group, which really is the most important thing. And so I did grade 4 here and then we moved back. So then I was doing grade 4 again, but I was used to these mad minutes. And so then in Sweden, it's all, you know, kind of, it's all hand-holdy. You want to talk about this multiplication for a little bit, and it's very wholesome and guiding you through it. And I was mad minuting all over the place, and I don't think they knew what to do with me. I was done. Yeah, it's not really the goal. Anyways, pretty funny. So quadratics, cubics, recognize those, and they can appear in kind of multiple ways. It can be a polynomial like x to the 3 plus 2x squared plus 4, right? Things like that. But as long as the highest power is 2, it's a quadratic. If the highest power of x is 3, it's a cubic. Okay. Obviously, x is just the placeholder for the input. You can use lots of different variables. You can use smiley faces if you want, but it might slow you down. Smiley face to the power of 3 plus 2, smiley face squared plus 4. You could do that. How about the reciprocal? The reciprocal is when you have 1 over the input. Okay. That's good to recognize. Also, the reciprocal squared. Right? Obviously, if you see the reciprocal, you'll also see the reciprocal squared. So we'll look at those. Square root, we've seen already. You can specify what root you want by putting a little number inside the, I call it the crook, but I'm sure that's not the proper term. Watch it be something basic like hook, which now that I say it, it might be.
Check mark thingy.
Yeah, yeah. I mean, I'll know what you mean. So yeah, I call it the crook of the square root or the hook, I guess. But anyways, in here, you can specify what root you want. So the square root, usually we don't write the 2 because it's the most basic root that we work with, but we can also talk about the third root, right? Which is kind of like the flip of x to the 3, right? The flip of the cubic is the cube root. Okay. And your calculator will be able to do it for you. Okay. All right. So these are functions that we're going to talk about by name often, right? And so it's good to, if you're not totally comfortable with quadratic, cubic, reciprocal, right? When I use that terminology, then, maybe have a little cheat sheet or some sort of Post-it note or something on the side until you've got that terminology down. Okay. Okay. So what are some things that we can do? Well, stealing this from the textbook. We're going to use these individual little pieces of a function to build bigger functions, right? So often we do a combination of functions, and that's why we need to know the building blocks. Just like learning the alphabet, I guess, in order to write. Although I don't really see how it helps, but maybe that's a stupid thing to say. Do you need to know the alphabet to write? I guess. All right. So it still works. I'm going to steal this. Maybe I'll steal this whole thing while I'm here. Oh, I wonder if, can you see? Oh yeah, you can see. Sometimes it doesn't show what I'm doing. So it's just the screen. We touched on it briefly, right? That there are going to be times where we can't write something as a function, right? Things like a circle. We said a circle doesn't pass the vertical line test. It's not a function. We'll still be able to express it as an equation, right? But it's not a function anymore. Okay? And so the equation of a circle is also one to remember, which is in this box here, but we're building up to that. Okay. And what it's built off of is what we call the distance function. Okay. So if we have the distance between 2 points here, the first point number 1 is going to be x1, y1. So any generic xy point, right, on a grid. Okay. And then, of course, point number 2 is x2, y2. Now we're given the distance function, and we could get there, but it would take too long for us today. So that's something I'll kind of keep in mind. Maybe we'll do it later, but let's just take it for what it is today, and we'll use it. So the distance between 2 points. So imagine here, right? You've got, I'm running out of space here. How about this? I've got x1, y1, and I've got x2, y2, and I'm trying to find the distance between these 2 points. Then we use this function. So the distance function takes the second value of x minus the first value of x. What's that finding? It's finding the difference in x's, right? And then we square that. Just take it as fact, how about? And then we do the same thing for the y's, right? And then we square that, right? So the distance in the y's, right, feels like rise and run, right? And it is, right? And so here's the run, here's the rise, square those, add those together, and then take the square root, right? Kind of a more sophisticated function right away, right? But this is the distance formula. Function. Or is it? No, but I can't support that right now. I'll think on it. Okay, so what could we do? We could use this, right, to figure out the equation of a circle, right? If I just take, I shouldn't say just, that's crazy. If I let this be my center, right, then what could I do? I could, oh, hopefully it'll, I didn't make enough of a circle. Let me try that again. Aha. Ish. Not very good, but right. So then we could find all the points that are that distance away, and that makes a circle, right? What's that distance? That distance is the radius, right? And so here, wait, just be cool there. How about that? Making that distance the radius. Okay, not bad. There. Yeah, got it all. Okay. Which leads us to the equation of a circle. Okay. We could say, okay, the radius is the square root of x minus h squared plus y minus k squared. Okay. And we're just using hk as the center. Right? In this case, we used x1, y1 as the center, right? But now just generically, we're going to use hk. Now, typically, we talk about circles that are centered on the origin, right? Which means that hk is 0, 0, right? That's nice. But generically, then a circle with radius r with center hk has equation r squared. What did we do? All we did was we said, okay, how about we move this square root over to the other side, making r squared, and then we have kind of a cleaner equation, right? R squared, x minus h squared plus y minus k squared. Okay? And so that's the equation of a circle, but usually, how about this? Often, the center is the origin, more terminology that I'm sneaking in. At the origin, are you guys okay with therefore? 3 dots in a triangle like that? Therefore, well, you are now. Sometimes I feel like I talk like an East Coaster. You are now. Aspiring. The origin means 0, 0, right? So it's here at the center, which means here, this is 0, 0, which is called the origin. Yeah. So usually that's what we're talking about in terms of a circle, but we can handle moving the circle around, moving the center around by this formula. Yeah. What would that do? If h is 0 and k is 0, all of a sudden you have r squared plus x equals x squared plus y squared, right? And that might sound familiar, right? But then oops, r squared is x squared plus y squared. But that's only the special case. Right. Okay. What are those examples? Let's find the distance between 2 points. And I'll grab that distance function for you because it's above here. Ha. There. It doesn't matter which one you call point number 1 and which one you call point number 2, as long as you're consistent, right? You need to stick to one script. Okay, but here we'll call this x1, y1, and we'll call this x2, y2, but you can play around with those and switch them around if you want, and you'll find that the distance between this point and this point is the same as the distance between this point and this point, right? So here we go. The distance is the square root of, now we want to find x2, which if I just map backwards, right, x2 is 2 and x1 is -3. Be careful preserving that negative, right? You don't want to take it from here to here, right? And so we've got 2 minus -3 squared plus y2 is -1 and y1 is 4. -1 minus 4, then square it. And again, careful with those negatives, but I like to just maybe confirm that I did it. Yes? Plug and chug. We plugged, now we chug. We leave the square root until the very, very end, right? And just like an onion, you have to work your way from the center out, right? And so inside each of the brackets, I'm going to work with them simultaneously, right? But 2 minus -3 puts me at 2 plus 3, right? 5. And then squared, but I'm leaving that for a little bit. And then -1 minus 4 puts me at -5. I want to square that. Which means 5 squared is what, 25? -5 squared is also 25. The square root of 50 is the distance. You'll find I do this quite a bit. If nothing's changing on one side, which is why I like to do my kind of switcheroos, right? If nothing's changing, you don't have to write it out, right? Until the very end, I like to clarify that, hey, just a reminder, this is the distance, right? Technically, you wouldn't even need to do that, right? I could just, oh yeah, it's the distance, right? But so that's just kind of a nice thing to have up your sleeve. Otherwise, you're writing distance. Crazy. Don't do that. I'm going to leave it in exact form, right? An exact value is things like the square root of 50. If I were to write the decimal, right, all of a sudden I'm at an approximation, and I'll know what you mean either way, right? But I'll just leave it in exact form. Which is the square root of 50. I don't think the square root of 50 is anything nice, is it? Yeah. Nah, I'll just leave it at 50. Yeah, because otherwise, what would I have to do? I could pull out some nice root, right? So what has your calculator? I'm hoping it was your calculator. Did you just do that? What did it do? It went like this and rewrote 50 as 25 times 2. And then it said, well, I can find the square root of 25. And because I'm multiplying in here, just to emphasize, I can rewrite this as the square root of 25 times the square root of 2. Now I'm being really bad and writing across the page here, but it's only to illustrate what it did. We're not quite here yet, but right, pulled out something that it can take the square root of. 25 is the maximum value, and then it rewrites it as 5 root 2, so 5 times root 2. Root 2 is irrational, so we're stuck, right? Still with a square root, and so for me, I mean, what's the difference? Root 50 or root 2? Either way, I don't really gain anything from doing all this work. Your calculator will do it, right? And so that's nice, but I'm happy with just root 50. Any questions about that?
So don't do that.
You don't have to do that. If your brain wants to do that, go for it. But it's not something that I'm expecting of you, right? But it helps to recognize that, okay, that's what your calculator is doing, right? When you go to check your answer. But if you find the decimal approximation of either of these, it'll be the same, obviously, because it's the same number. Yeah. Depending on what field you're in, a lot of the time they want you to reduce to kind of the smallest version of the number, which would be this. Okay. But I don't care. Okay. I guess I should say I don't care. I don't care. But I don't care. let's kick it up a notch. Oh, okay. Let's just draw this real quick. Just so you can see what we just did. Point number one was at -3, 4. This is obviously not to scale. I'm not going to spend any time doing my ticks or anything, but I will just jot down. So x is -3, 1, 2, 3. Y is 4, 1, 2, 3, 4. I'll do ticks, but they're not very good. This is -3, 4. And the second point was at 2. So 1, 2, -1. 2, -1. So what did we find? We found the distance here is the square root of 50. What does that feel like? Feels like a squared plus b squared equals c squared, yeah? Well, it is. All right, I can draw an imaginary, oh, well, it should go through the little point at -1, but whatever. Right, first we found this distance, right? The distances between the x's. Then we found this distance, a squared plus b squared equals c squared. Take the square root and you're at 50, right? So you can confirm it visually if you want to. Yeah. But that's what we did. We just have a formula to use so that you don't have to do it like this every time. But you could, if you want to. All right, so now find the equation of a circle centered at -3, 5. Let's start with the graph. 1, 2, 3, -3, 1, 2. Oh, I didn't do a very good. 1, 2, 3, 4. Because I need a radius of 5, right? And so I'm just going to say that this is not a distance of 5. How do I do that? 1, 2-ish to here, right? I'm going to force this distance to be 5. And then I'm going to draw a circle. Okay, well. I feel like it needs to be a little bit bigger. Ish. Not very good, but that's the idea. Okay. And so we have the equation of a circle at any, I'll just grab this, I guess. At any center, which we're not just centered at 0, 0 anymore. We're centered at -3, 5, which means that h is -3 and k is 5. So then r squared, I'm just going to write out the equation that we're going to be using is x minus h squared plus y minus k squared. We know some things. And so r squared, well, r we were told was 5, right? We're forcing the radius to be 5. So x we don't know, that's okay. We're gonna keep it open, right? To be able to draw that whole circle, right? We wanna be able to do all values of x, but h was -3, then squared, and then plus y minus, forgotten already, 5 squared. Wonder how far we should take this thing. 25 is x minus -3 is the same as x plus 3 squared plus y minus 5 squared. Should we rearrange in terms of y, right? I have some input x. I want to find what the y is on this circle. Sounds reasonable. All right, all right. What am I gonna have to do? I have to, and I only have 2 lines that I'm gonna do it in because I want to keep it on the same page. I told you I'm a slave to these page breaks. Anyways, so choose my moves carefully. I'm gonna move the y minus 5 squared over to the left-hand side, right? Because I want to solve for y. I'm also in the same move gonna move 25 over, so I'm gonna switcheroo those guys, subtracting both, right? So where does that leave me? Leaves me here at y minus 5 squared, but negative, right? I have to subtract it from both sides. Maybe I've bit off more than I want to chew. Minus 25, we'll see. Maybe I need to buy myself more room. Fine, one more line. Can I do it? Well, we'll see. Okay. Oh, yeah, what a mess I've made. All right. I'm going to keep the x plus 3 squared just as is, because why did I say what a mess I've made? What do I have to do? I have to multiply both sides by -1 to get rid of this negative, right? And then I have to take the square root of both sides, and then I have to add 5. I've made a real mess. How about we don't do this? Eee! Mostly because class is over. But I know, right? You're just waking up. I know. How about this? I'll keep it here. We'll end here, but when I post the notes, I'll keep the worked out version in here, and then you can check your work. How about that? All right. Any questions? Have an awesome weekend. See you on Monday.
So that
Yeah.
assignment, when's that due? Or
I made it due. Did I make it due this Friday or? Yeah, it's this one, section 1.1. So we just finished 1.1. So now you have everything you need. And it is due next Friday. I like to give you a week from when we finish the material, unless there's, tests or whatever. But do you guys prefer a Friday due date or a Sunday due date? Makes no difference to me. I'm trying to give you guys a weekend off of math, forcing you. No? All right. The 24th then.
Yeah.
I'll stop this recording.